All right, let's 3D scan a DC motor mount gear enclosure. This is just something that I yanked out of a poor robot vacuum that I'm turning into a terrible little wannabe BattleBot. But it needs some modification, and rather than just going at this with a Dremel, I wanted to print something custom. But before I did that, I would need to get the proper dimensions, and I have calipers, I can use calipers, I don't feel like using calipers. I could 3D scan it, but very dark black, shiny ABS, not the easiest thing in the world to scan. Unless you've got laser beams. Now, scanning with lasers is a little bit different. I know it's kind of hard to see, but on my screen here, we have a few different options you're probably not used to seeing. Point distance, that's going to be how fine of features you want to capture. The tighter it is, the longer it's going to take you to scan, but you're going to capture those finer features. The wider it is, the fewer points you need to capture. It's great for large flat surfaces, but it really depends on what you're capturing. It's going to take a little bit of getting used to figure out what setting you need. Cross line and parallel lines, basically that's just your X's versus your straight lines. Cross lines is much faster. Parallel lines can give you higher accuracy, but takes realistically twice as long. Object type is going to be a black object. And if you're used to Revo scan, just scanning distance, that's nothing new. I am using global marker mode. That's just because it speeds things up a little bit. You're not having to worry about marker acquisition while you're scanning. You're already working from it. So let's go ahead and start our scan. Now, let's go ahead and make sure our surface is nice and easy to see. Not doing that. We're scanning black. So, similar to what you're used to in Revo Scan on the other side of the screen, you've got your depth exposure. That's nothing new, but you've also got your laser brightness, which indicates, well, how bright your laser is. So, if I take my laser brightness way down, you'll see on the screen here, it's more jagged, it's harder to see. So for what we're wanting to capture, you want to make sure you get as close to a solid line as possible. And if it's not quite good enough, you can turn your exposure up. But generally speaking, I like to start with the default or maybe even just a tad below. And then if I need to, take it up from there. And let's start. I'm going to go ahead and do the full screen on that. Now, this is going to look significantly different than what you're used to scanning with any Revopoint scanner. Right out of the gate, kind of similar in terms of the distance bar, but everything else is different. So you'll see there are green lines and blue lines appearing on my screen. And I'm going to pause so I can demonstrate, but what's going on here is essentially I'm painting the surface of the object I'm trying to capture. And as I do these sweeping motions, it's getting data points for wherever it can see the laser lines. Now, unlike a full field or structured light scanner, which can essentially gather a photo, a depth map all in one shot, with this, it's gathering so many frames per second, but the frames are only capturing where the laser overlaps and the scanner can see it. So it does take a bit longer, but you're getting a far more accurate, higher quality scan. You want to keep the scanner moving, and you're going to, I keep saying it's like painting. You want to just kind of glide it over the object you're trying to capture. And you'll see I'll pause frequently just to change my angle. You don't really have to do that, but it's just the way I operate. And you can also, of course, use it in a horizontal orientation to help you see more of the markers from a lower level. Because at the end of the day, the depth sensors are like eyes. And if they're on the same plane as the object you're scanning, well, they can see more. But you know what? If you're watching this, that doesn't show you what you want to see. I'm going to go increase my exposure a bit because the glossiness of this object is making it a little bit trickier for the scanner to see. Now I'm going to do a quick pause. You can see we've got different color features on our object. So green means it's captured a good amount of detail, a lot of surface. Orange and red means very sparse, very low detail. So when I look at some areas like this flat area here, I'm going to want to get the scanner kind of parallel to that because of the type of surface we're working with. Now, if you're looking or working, excuse me, I'm bad at speaking, with a more diffuse or rough surface, lighter surface, the angles are a lot easier to get around. But with something like this, you're going to get the best quality scan by getting that parallel angle. Now, the marker blocks are a huge, huge help on an object like this. Something this size, pretty small, I don't want to put marker dots on it. And that's just because of the fact they're going to create holes in the mesh that I'm going to have to clean up later. So to get around that, I've got my marker blocks, and I'm actually using, I've got the pad here that came with my Morocco, and I've got a turntable base on a printed base. And that's just so I've got as many tracking markers as possible to lock onto while I'm scanning to help me get the best possible scan. Now, sometimes I don't think ahead, and when I just put something down, I want to capture this flat side of this motor enclosure here. I'm kind of blocking my own view a bit with that pyramid marker and the two stacked smaller ball markers there. But I can probably, still going to get that. Not going to be the best, and I am still missing some of it because I can't see all of it, but that's user error. Didn't plan this out. When you're scanning, doesn't matter what technology you're using, think about what you're scanning and how you're going to approach it before just, getting all kind of gung-ho on it. Now, because of the fact I cranked our marker density all the way down, or not marker density, our point density to the lowest setting, I need to put in a lot more work to get all the details on this object. Had I left it at the default of 0.3 millimeters, that would have been more than enough for this, but there's no kill like overkill, and sometimes you just want to do that nice sweeping motion, do a little bit of channel your inner Bob Ross, painting the surface of that object. Put on some tunes, enjoy yourself, do whatever you want. It's an oddly zen thing compared to normal scanning, or just popping something on a turntable. You may be tempted to use a turntable for an object like this. I don't know if I'd recommend that. If you do, you're still going to want to go ahead and scan it by hand and not have the scanner on a tripod. Because what can happen is, as the object is rotating, the laser lines are going to kind of stay in one spot on the object and kind of create a high density ring of tracked points, while other areas don't get the same amount of capture. And what can happen there is it'll create, I don't know what to call it. I don't know if it has a name. I'm not a professional 3D scanner, but I call it burn-in, where the lasers have basically burned a ring in the point cloud that you've captured. And so it'll require maybe a little bit of extra cleanup. Now, if I can zoom in while I'm scanning, if it'll let me, you can see, okay, the top of this motor mount is looking quite good. The edges down near the bottom, I need to get considerably better. And I can get those just by slowing down and wiping those laser lines across the surface. And you can see right down, right about here, it's improving much faster than over here. And that's because I'm trying to scan around this marker block. Which again, think ahead. Now there's nothing stopping me from doing a second scan from a different orientation as well, and then merging. Because one thing I can tell you is with these laser scans, the merging is so clean. Now I want to let's pause and inspect. This is looking much better here. This area is, I just put myself in a bad spot with that marker block. I might have to come back to that separately. But I want to get a little bit more in here. And this side, yeah, that's going to look horrible because I haven't really paid attention to that. If the scanner can't see it, it can't capture it. Yeah, see this side, I have a lot more work to do. Hope you like looking at my forearm. Actually, let's give you the best possible angle. It's the same process, just swiping back and forth. Now, if you look closely at the scanning plate I'm using, it's actually one of the turntable mats that will come with many of the scanners you can get. And all I've done is added some 3mm markers to it as well. And that's just because the higher density you have of markers in laser mode, just the easier time you'll have. Now you'll notice this large flat area, it's looking pretty rough still. That's because it's at a bit sharper of an angle to capture. But if I can get that just like so. Now you might see on my distance meter, I keep getting way up at the top and too near. That's just picking up the actual scanning plate I have it on. That's not a big deal. I don't care about the quality of the scanner plate. Yeah, that's the good motion. Doing that little sweeping back and forth and pivoting a little bit as you change directions allows the laser to see the same features from many more angles, which will speed up the point capture and the quality of the surface you're getting. So we can see here is looking better, and you can see the point density differences in my point cloud. Some of that's just showing through from the other side, but some of it does need to be captured a bit more. I definitely have to get from this angle over here, which is a little bit harder to do when, you know, you're filming, but hey, let's keep going. Let's hold that wire so I don't knock anything down. I'll tell you, one of the last things you ever want to do, I'm speaking from experience, is knock down your marker blocks while you're scanning. Let's hold this. How can you guys see? Sorry, you're going to get my forearm. But the point cloud is getting much cleaner and sharper on this side now, rapidly. Let's pull back and get some of the back of this here. For an object scanned in laser mode, generally speaking, you're going to want enough room to move around to get as many sides of the object as possible. But trying to demonstrate, I didn't make the best choices. Hey, that's okay. You're learning with me. The scanner's in beta, and so am I. Wow, I really am channeling Bob Ross. Now this surface here, these sides, typically you would really want to come back and do a second scan with those in a more favorable orientation, just because of the fact, not only are they at a hard to scan angle, they are actually facing more downward toward the plate than anything else, which means even with marker blocks, you're putting yourself in a very tight spot to try and scan. But what's life without giving yourself a challenge? Go and turn our exposure a bit. You'll see those lines are getting a little bit more like a dotted line than a solid line from the shallow of an angle. So to increase our captured points, we're going to boost our exposure a little bit. I did put myself at a disadvantage with the angle of that. That's okay. I still think I'm going to put this in my showcase when I'm done. Now, something to keep in mind too, this thing will not capture with structured light unless you use spray. How do I know? I've tried. And that can of spray I was messing with at the beginning, it's empty. So, yeah. I've been wanting to get this scanned. Now, something that's really great about the laser is it can help you get into these tighter areas that can be really tricky when you're dealing with a regular scanner. So if we zoom in here, this is the kind of area I'm talking about on an object. It would be very, very hard to capture the inside corner here with a structured light scanner. Still need to get that a little bit more there. Just keep painting those blue lines. The area I'm focusing on right here is a very tight area for the motor's wire clip, well, for the motor's wires to pass through. Now I'd like to capture that as much as possible. Normally, getting a pocket like that, that's just not going to happen, but I can lock the zoom at all. You can see the lines are actually passing through the inside of that pocket as I do my passes. That's letting me capture way deeper down in there than I normally would. I can see up here, I've got a gap where there's a screw post. So let's go ahead, try to focus in on that a little bit. There we go. It's almost like magic when you're doing it this way, just seeing the points appear as the laser lines pass over. Boost my exposure a little bit because that's a very shiny spot. I think we got enough for this. Probably went a good deal overboard. But I said it before, there's no kill like overkill. Yeah, I'll have to reorient and do a second scan. I could have done much better here, but that looks like it came out pretty alright. It's probably still gonna be a little bit not great. This side I'm gonna want to hit from another angle. But the main angle is going for this overview here. That's fantastic. All right, let's mark this complete. From this point, it's just your standard Revo scan process. So Now, you're probably not used to seeing a raw scan that looks like this. This is pre-processed. This is just raw point cloud. So you're getting at this point a pre-fused point cloud that I've created fused point clouds that don't look that good. Let's see. It recommends 0.42 on this, but that's probably because it's picking up a lot of this outer area, that overscan, and that's just because I was scanning a black object. If you're scanning it in normal mode, it doesn't pick all this up. Let's go ahead and measure that. I think the thinnest part on this was really only about 1 mil. Let's go with marker points too. Create some tiny holes. And let that fuse. That's going to take a second because I captured a ton of frames. Let's run our isolation. Oh, that's nice. I am loving that. Let's go ahead and clean this up. If I click the tool. Control-Shift-I, by the way, if you're not aware. Yeah, I didn't do the best job from that side, but we knew that. It's not the tool, that's the user. Let's do one more isolation, just get anything I missed. All right. Wow. Barely any overlap to detect. That's how you know you got a good scan. That removed 21 points from the entire cloud. Watching the point count on the side here. That's fantastic. That's good. Yeah, let's do that point. Let's measure at 0.2. 3 minutes, no. Wow, look at that. Move my light around a bit so I can get a better idea of my edges here. That's not bad at all. I fuse at a pretty low resolution too. Oh, I will take this. Every day of the week. We got way down in that pocket. Not only did we get this, but we got the flat part below it. This rounded edge came out great. I am very happy with this scan. I'll go ahead and attach some screenshots of the final scan, and I'll probably scan this in parallel mode as well, and I'll go ahead and share the final results.